Coding with Primary Learners by Rebecca Vallis. To set the stage, for the sake of clarification, I'm going to start this presentation with the preface that, from my own experience, I would highly recommend coding with tablets for grade 1 or younger and starting Chromebooks in grade 2. Not only do programs such as Scratch Junior, intended for ages 5 to 7, only come available as an app and thus not available for computer usage. But the introduction of the computer in the classroom in grade 2 means that at least a few of your students will already be familiar with the computer from their own home usage, and thus there are extra helpers in the room to problem solve technical problems with friends, such as where to find the period on the keyboard. Here's some personal background. As a regular grade 2 in-person teacher following a curriculum that says students need to be more computer savvy, I make it my prerogative to introduce the Chromebooks to the class around December. This is always a challenge in and of itself because everything is a mini lesson. For example, how to carry Chromebooks properly, how to treat the Chromebooks with extra care, how to wait patiently when you are having trouble with your Chromebook. What is an enter key or a spacebar key? An incredible amount of patience is required, especially since some students have never been introduced to a keyboard, since they may have a tablet at home and thus have never used a computer prior to your class. So the first obstacle is always introducing a computer and showing students how to use the keyboard by playing a game such as BBC typing practice, and then moving into some simple math game websites such as mathplayground.com. I began teaching code in my grade 2 French immersion classroom 2 years ago. I had no idea what code really was or how I might teach it, but my husband encouraged me to try out the website code.org with my students. With code.org, there are instructional videos that tell students what they are learning and how to play by writing code. There was no need for me to elaborate, as the children tended to problem solve on their own, and I was not shy about asking any of the tech-savvy grade 2s what to do if I ran into any tech issues. What to overcome? Teaching code for the first time in a primary classroom can be overwhelming, as children tend to be vocal when things are not working, or they don't know what to do with a pop-up, or they've accidentally clicked the wrong button, or they can't figure out how to use the shift key, or. But aside from classroom management concerns, teachers, as per a survey by Rich et al., tend to find the following concerns to overcome. Teacher preparation. It can be overwhelming to perhaps participate in an afternoon of professional development on coding and somehow manage to glean enough expertise to feel comfortable in the classroom being an expert on coding. There are problems not having enough computer or iPads. This is a reality. There are connection problems, which is networks and speed can become difficult. There are challenges getting software onto computers or tablets. There are often passwords that only tech experts at the board are privy to for downloading software. So this can slow down a lot of your progress. There are problems with lesson plans or lack of resources. Sometimes I find that it isn't the lack of lesson plans, but having to filter through random websites with random plans, trying to find something that will fit your class. But let's look on the bright side of the positive side of coding in a primary classroom. You are new to coding. Teaching coding in primary is the perfect place to be. As you are teaching basic coding practices, you can learn alongside your students. So in the study by Rich et al., when teachers are asked to give advice to other teachers considering starting coding with their students, nearly a third of all teachers, that's 32% in the study, recommended to other teachers that they jump in, have a go, or just start. As one respondent put it, "What are you waiting for?" The best place for you to learn is by jumping right in. So here's a question. What could coding with primary learners look like? According to Rich et al., in Coding in K-8 International Trends in Teaching Elementary or Primary Computing, coding is 21st century education. Although, as per Rich et al., there is relatively little research about those actually teaching computing in the primary grades. All in all, coding with primary learners looks like instructing young children to program machines by issuing a series of commands. It also looks like the use of text or block-based languages. The machines may be computers, robots, or microcontrollers. But a very important fact is that coding with primary learners looks like teachers learning. So what might work in your classroom? I would vouch for programs such as Code.org as well as Scratch Junior and Scratch. As per surveys administered by Rich et al., the Scratch programming language was easily the most taught computing coding language, more than doubling the next closest language, thus attesting to its usability. Also, code using blocks, Scratch, Code.org, and Lego Robotics, tends to be easier to use for students, and, as research states, the most common languages to teach kids to code involve using visual blocks, as represented by Scratch, Code.org, and Lego Robotics. To clarify, research shows that in all likelihood, Scratch is being taught at the lower primary levels, while Python and JavaScript are being taught to the older students for simply the method of giving the younger students a simpler, easier language to grasp. The basis for using code blocks is that younger students not only seem to easily grasp the block, move, and click action, but according to research in future grades, students seem to seamlessly translate to real programming languages, meaning that the block-based coding isn't setting them back. So, can coding be integrated in other subjects? The easy answer is yes. How? That would be depending on what resources you seek out from your board, your colleagues, your administration, or the internet. As per the research done by Rich et al., teachers reported that they taught computing, coding as a standalone subject nearly twice as often as an integrated subject. When teachers taught computing or coding as an integrated topic, we found, perhaps expectedly, that computer coding is most often integrated with mathematics, followed by science, language arts, engineering, and social sciences, which means that it is perhaps easiest to start with mathematics in your classroom by integrating coding into your mathematics program. Notable findings. On average, more than 55% of teachers had no or very little training with computing or coding prior to deciding to teach in the classroom. So that's of the teachers that were surveyed. And this means, really, that you can teach coding too with the right motivation. Teachers that begin coding in their classes teach coding because of the perceived benefits, whether it's future job opportunities for students or the benefits of problem solving. Furthermore, teachers noted changes in their students since starting to teach coding. Students improved in problem solving, attitude, and resilience. As one teacher put it, they realize it's okay to fail when coding because you can just try again. Another stated, they have become more comfortable in making mistakes. That is a natural step in thinking and creation. Personally, I have watched students try a line of code by pressing the start button, get it wrong, add another line of code, only to get that wrong. But then they add another line of code and suddenly it's right. The trial and error allowance given to students when coding offers students a safe environment in which making mistakes is simply a part of the process. Finally, teachers should be willing to learn with and from their students. Technically, when you walk in and you are not perhaps the expert, sometimes you'll find the experts already in the room with you. So learning with the students is a really important part of beginning your coding, especially if you don't have the background. Benefits of coding. In respect to the benefits of coding, according to Gadanitis et al., computer coding in the K-8 mathematics curriculum Students, 1. Understand in a tangible way the abstractions that lie at the heart of mathematics. 2. Dynamically model mathematics concepts and relationships. And 3. Gain confidence in their own ability and agency as mathematics learners. An included benefit is enhancing student conceptual development. Where can primary students go with coding? The answer is the sky's the limit. As per Gadonitis et al., the coding environments available today, especially those that are blocks-based, offer a low floor, allowing engagement with minimal prerequisite knowledge, and a high ceiling, offering opportunities to extend learning to more complex concepts and more varied representations. Not only does this allow students to explore the endless limits of their imagination, especially for those students who excel in coding, but this also means that coding in the classroom supports differentiated learning, as students can gradually build on their skills at their own pace. So just to go into some backwards planning for coding. In the curriculum outcomes, your grade 1 student, your grade 2, and your grade 3 have the same outcome with a bit of scaffolding. So the outcome is solve problems and create computational representations of mathematical situations by writing and executing code, including code that involves sequential events. Grade 2 has to do the sequential events, but it does involve then concurrent events. And then grade 3 adds on to the sequential events, the concurrent events, and entails then repeating events. Another outcome is the students need to read and alter existing code, including code that involves sequential events, and describe how changes to the code affect the outcomes. Again, it's the same for grade 2, except the sequential events include concurrent events, and in grade 3, the sequential events, concurrent events, and then it's the repeating events as well. So, what resources are allowed? When it comes down to programs for Scratch or for coding, you do need to check with your school board, because some school boards, for example, may not allow code.org, such as the school board that I'm currently working in. Whereas another school board that I was just working in as well last year, they did allow code.org. Or, for example, and one school board may allow Scratch and another might not allow Scratch. So this is always important to check with your school board's tech list. And finally, here's some examples to put coding into practice. I have added in the comments, the YouTube block comments for this video, these 3 websites. Very specifically, these websites are great keys to other teachers and educators that go through a more thorough lesson plan for the very first time students use Scratch Junior, Scratch, or code.org. These are great tools for introducing code into your classroom, and I believe that you'll have a lot of success simply by watching a quick video and then seeing what your students can do. Thank you for listening to this presentation. I hope you've learned a bit about coding with primary learners, and here are some references.